Good day, my name is Ezugwe Bukapita, and this is my final year project, and I'll be this for your viewing pleasure. So what I'm basically doing is the equipment development for force sensing using octagonal rings. There are different equipment that have been developed for force sensing in recent years. You have the tool shank method, but this method is the octagonal ring method, which will have strain gauges placed on them. So from this um, diagram placed here, you can find that this is our front view of what the dynamometer would look like. This is the rectangular base plate that will be placed in the tool box of the lathe machine at a particular angle. If you place it this way, you find out that you can place your toolbox in that particular angle, and this is where our tool will be in. And these are two base plates made out of mild steel or iron or whatever. Then the rings are basically, the materials for the rings are mild steel. They were well, taken out care. They were well taken care of. Sensitivity, rigidity, and stiffness were put into designing the dimensions of the rings, for which you have T over R to be relatively 0.25. For you to have maximum sensitivity, rigidity, and stiffness for the rings, your T over R for the ring should be approximately 2.5. This is the value that has been given to us right from time. So this design has been well thought of. And this is the side view for our dynamometer using the octagonal rings. And you can see tiny dots. These dots are basically what we call strain gauges, and they are very important for this design. Basically, they are what converts the strain in the rings to deflections, to elongations on the strain gauges, and into variations in resistances, into voltage values that will be calibrated into force values, basically. Then this is the force coordinates for which we are trying to get our forces when we are working on the lathe machine, because forces are very important in lathe machines. It helps us to understand what particular depth of cord, what particular speed, and what particular um, spindle speed and feed speed we need to work with in order to get the perfect geometry for our tool, for our workpiece. And this is our Wheatstone bridge, and this Wheatstone bridge is basically just for the FX direction, the FS direction. So basically, if we have our octagonal rings and we have strain gauges mounted on both sides of the octagonal rings, you have four octagonal rings, by the way, four octagonal rings on this design. Two rings are facing the same direction, while two rings are facing the opposite direction. Now, two rings facing the same direction would be measuring the force Fx. Now, if we have R1 and R2 supposedly placed here and here from the Wheatstone bridge, R1 and R2, you'll find out that if I have a force Fx on this direction, if I have a force Fx on this direction, this is the force Fx. This, my ring here, this one, will undergo tension. And if it undergoes tension, the one on the opposite side, which is R2, which is this one, will undergo compression. Now, if it does that, there will be a variation in the Wheatstone bridge circuit. But it doesn't end there. It doesn't end there. There's another ring on the other side that would also undergo a tension and also a compression, which makes us have a full Wheatstone bridge circuit. This is what we call a full Wheatstone bridge circuit, because we're using all four arms of the bridge. And using the full Wheatstone bridge circuit gives us the maximum voltage that can possibly come out of a Wheatstone bridge. So at that particular point, we're getting the maximum voltage that will be calibrated to give us the maximum force. So for every force that we get on the lathe machine, we are very sure that we did a very good job on the Wheatstone bridge circuit. So basically, this is how you get the Fx direction. The same thing works for the Fz direction. The same thing works for the Fz direction. The rings who are facing the same direction will measure the forces on those direction. You find out that for the Fx direction, only the strain gauges mounted on that direction are affected. So you have what they call cross sensitivity, and you find out that if you have done a very good job on this design, you find out that your cross sensitivity will be very, very low. You can't eradicate cross sensitivity, but definitely you can reduce it to the barest minimum. Then for the FY direction, this is where the explaining comes into play. We would have 8 possible gauges working for the FY direction. 8 possible gauges working for the FY direction. You have, take for instance, the ring on this side has a gauge on the inside and one on the outside. The same thing happens here on the inside and on the outside. The same thing happens for all 4 rings. 4 times 4 is 4 plus 4 is 8 basically. 4 plus 4 is 8 basically. So that is what you have for this particular Wheatstone bridge circuit. 4 plus 4, 8 gauges working for the FY direction. Now, if I apply a force, see for instance in the FY direction coming down this way, just the same way this coordinate is, if it's coming down this way, it's going to compress my rings. Now, if it compresses my ring, you find that the strain gauge on this side will be in tension, while this one will be in compression. The same thing happens for all the 4 rings. Now, if there's a variation like that, that is how we calculate the force in the FY direction. So basically, this is how the equipment development for force sensing would be carried out for my final year project. Thank you.